So now I'm delighted to introduce another colleague who I haven't seen in a long time, but I'm just delighted to see her again. And it's Professor Cindy Atman. Hi, Cindy. How are you?
Hey, Louie, I'm doing fine. How are you?
I'm good. I'm good. Just great to see you. Cindy's the director and Lela Blanche Bowie Endowed Chair in the Center for Engineering Learning and Teaching and Professor of Human-Centered Design and Engineering at the University of Washington. I'm sorry, I'm calling you Cindy because, is that okay? But
Totally.
I think what I'm going to add to that is if there's anybody who's been a pioneer in advancing the world of engineering education, it is Dr. Atman. And we're just so delighted to have you here, Cindy. So let me thank you very much for being here and turn this over to you, okay?
Absolutely. Thank you so much for the invitation. What I'm talking about today is my work researching and teaching in engineering design. But first, what I'd like to do is invite you to fill out the following. In 2040, the engineering graduate who wants to X might need to know Y and could learn it by Z. You can imagine there's so many possible responses here, and I'd like you to look at this list and see if what you thought of is represented in this list here. This list came from 77 engineering design educators from the 2017 Harvey Mudd Conference on Engineering Design Education. And by far the top response from this group of educators was that engineering graduate who wants to change the world, have an impact, make a difference, all the kinds of things we've been talking about the last couple of days here. And you could imagine there's so many different ways to combine the X's, Y's, and Z's. And today I'm talking about one particular thread, and that's the work I've been doing, NSF-funded research on the engineering graduate who wants to change the world, might need to know how to design, and could do that, accomplish it through reflection. But first, we've been asked to talk about our own pathways, and so I'll tell you a little bit about my experience. My lifetime goal was just the same thing, to change the world, and maybe that's what a lot of the listeners to this conference have as a goal as well. And so in my family, there was an expectation that you were an engineer, so I was like, okay, I'll change the world through being an engineer. But a little twist got thrown in on the graduation day. I was graduating with my bachelor's degree in industrial engineering, and a mentor took me aside and said, you should think about getting a PhD because we need people like you teaching at the university level. And I was like, what? I had never thought about that in a million years. So then life happened. I worked in industry. I got a master's degree. I worked in industry and then on Capitol Hill. And then it came time in my life to get a PhD, and I became a faculty member. And I realized at that point that not only could I change the world as being an engineer myself, but I could also help teach engineering students how to change the world themselves by helping them learn how to think about the impact of engineering on society and the globe, to consider context in their engineering work, and to minimize things like unintended consequences. Well, if you're going to teach something, you need to know how to define it. And I turned to the definition of engineering by Bill Wolfe, a previous president of the National Academy of Engineering. And I love the elegant simplicity of his definition. Engineering is design under constraint. Constrained by what? Well, constrained by a whole lot of things. Constrained by nature, by safety, by environmental concerns, cost, reliability, constrained by all kinds of things, which is one of the places where you can be looking at context. But he also goes on to talk about engineering as being absolutely creative. It's designing what can be. It's like you taking your imagination from the list you came up with before and imagining it as an engineer being able to accomplish that goal. So if engineering is design under constraint, what does that do to my lifetime goal? If I'm trying to help teach engineers to change the world, then what I needed to do was focus on teaching engineers how to design. So my more refined lifetime goal became to deeply understand the doing of engineering design, so that could inform design teaching. NSF absolutely enabled my career. I got graduate student funding as a student in engineering and public policy at Carnegie Mellon. I was awarded the Young Investigator Award, which is a precursor to the current career program. and had multiple traditional grants. And then I was honored to be the director for the first center-level funding for engineering education research at the Center for Advancement of Engineering Education with some amazing colleagues from across the country. And Sherry Shepard is the discussant for our session, so you'll be talking with her later. Today, I'm focusing on the Young Investigator Award funded work on design expertise research. Recall my goal, deeply understand the doing of engineering design. You can develop some more refined questions of how do engineering students and experts engage in design? And are there differences between students and experts that can inform us how to teach design? So I embarked on a quest funded by NSF to use research methods from cognitive science to run lots of experiments. I have data from 177 engineers with various levels of expertise, and this is a really large sample size for this particular research methodology. Each person solved a design problem out loud, and then I created quantitative measures from that qualitative verbal data, and I was able to compare processes across levels of expertise, so comparing experts and novices, for instance. Today, I'm going to be talking about data from 50 of those participants who I asked to design a playground for a fictitious neighborhood. And this is a schematic of what the experimental setting and the data look like. I'll be talking about data from 26 incoming first-year engineering students and 24 graduating seniors. Each individual in a lab-based setting had up to 3 hours to do a design. They talked out loud while they did their design, and we took their solution then, after they were done, we took the solution and we evaluated the quality of the playground that they designed. And then we took what they said, that was our process data. We transcribed the audio files, transcribed them into paragraphs, and then segmented the paragraphs into phrases. And then we took what we call the design code and assigned it to each one of the phrases. So what the heck is a design code? A design code is basically a way to describe the activity that a designer took at a given point in time. And we turned to how we teach design to engineers to figure out what codes to develop. We looked at 7 engineering design textbooks and did a content analysis and found a common language about engineering design. And that's what you see on the right of the screen here. First, identify a need, which is grayed out in this case because we gave them a need to design a playground. But then our students proceeded to define the problem, gather information, generate ideas, model or prototype their ideas. In this case, that would be something like sketching out a slide or a swing set, doing feasibility analysis, evaluation, decision, communication, and then implementation again is grayed out because we didn't ask them to actually build the playground. They were doing a conceptual design piece for this participation in the experiment. So what did we see? What did our data show us? Well, we found that graduating seniors were significantly more likely than first-year students to have higher quality designs. We were supremely happy to see this. Our graduating seniors did better quality work than our incoming first-year students. But in addition, lots of process things were different. They made more transitions among design activities. They scoped the problem more effectively by considering more categories of information. And they progressed what we call further into the design process. And I'll talk about that in a little bit. So those were fabulous results to see. But how do we actually look at the data? What we did was we took each individual's design process through their utterances and all of their codes, and we represented each individual in a timeline. What you see here in this representation is on the left, you see those activity codes we talked about, problem definition, gather, generate, etc. And this is a timeline where time goes from left to right. And if the person spent time in a particular kind of activity, a slash was put on that line. So for example, do you have a list of materials? Was coded as gathering information, and that got a slash on the gather information line. So you can see how this person allocated time across these codes when they were doing their playground design. Next slide is a busy one. We're looking here at first-year students, 3 first-year student timelines on the left and 3 graduating students on the right, and 1 each for low quality playground design, middle quality design, and high quality playground design. Now I'll let you sit with these timelines for a moment and see what kinds of patterns do you see. For sake of time, I'd like to draw your attention to two of the timelines, the first year student with the middle quality design and the graduating senior with the high quality design. And what you see here is that the top timeline here, many of the incoming first year students read the problem statement, gathered information for a little bit, generated a couple of ideas, settled into modeling, and then stuck with modeling the whole time. In contrast, what you see with the graduating senior, more of the graduating seniors had higher quality, as we already said, but what you see with their process here is a lot more fluidity, a lot more complexity and agile movement from one activity to the next with the graduating seniors. And I'm going to take that timeline, the high quality graduating senior, and use it as a canvas to talk about movement towards more experienced design behaviors. So what we see with this student is on the right-hand side here, the top one, this student spent a whole lot of time in what we're calling problem scoping. That is understanding the problem before you choose what you're going to be doing modeling. It's gathering information and generating ideas and going back and gathering information. This is where you bring in the idea of context and thinking broadly and thinking about things like use-inspired research. On the second timeline here, we also see that more experienced design behavior includes gathering information throughout the entire design process, not just at the beginning. When you're engaged in design, you find out that you didn't ask the right questions in the first place, or other questions come up and you have to ask them continually throughout the process. The third timeline here is just a focus on what you see throughout, and that is the fluidity of transition and iteration across activities. And then the fourth one is absolutely, you do need to stick with things at certain times as well. So you can't just iterate throughout. Next, again, what we see, people with more experienced design behaviors have sort of a shape to their design. We call it a cascade shape, where time, when these are ordered in this way, time is spent mostly in the upper left at the beginning and cascading down to the lower right at the end, which one student who saw the timelines called the ideal project envelope. Okay, now what? So I did a lot of work deeply understanding the doing of design. How can that inform design teaching? Well, how do we typically teach design? Design is typically taught with abstract models where those codes that I talked about before are placed in boxes and they are connected by arrows. And people say, do these things and remember to iterate. So what we've done in classrooms is augment the abstract models by complementing them with design timelines, which is a way that you can see abstract concepts like iterate, meaning go follow that arrow in the abstract model. You can see what it looks like with concrete data with the timelines. And we find that students really resonate with this. For example, one mechanical engineering student who engaged with the timeline said, super valuable, much more compelling to see real data, detail, makes me believe instead of tuning out prescribed information. A graduate who worked with the timelines when he was here working with me contacted me the other day and I said, hey, do you still remember the timelines? And he said, absolutely. If I ever find myself getting stuck in one mode or stage, I remind myself that the iterative cascade is where the magic happens. So what are we doing now? Current work is trying to make this work accessible to a larger audience, and we're doing that through an app and a seminar. The app we're calling Design Signatures app, you can see that the timelines sort of look like a signature, and every design project has its own unique signature. So if you Google Design Signatures app, you can engage, you can code your own design processes and create your own timelines and allow you to reflect on your own design processes and what you might want to change in your process. We're also leaning into that creativity that Bill Wolf talked about, and inspired by the beautiful Dear Data project, we created a seminar called Dear Design, where we have students every week for 9 weeks dive in, do a design process, and represent their process and interpret it through a different lens, deeply reflecting on it. This here represents students' ideal design signatures or who they think they are as future designers. Here's one student's progression through all 9 weeks of the seminar, and you can see all her creativity. And she said it really helps her to realize people do design differently, helps her collaborate, and that her ideal design signature, she says, is a core part of the work that I want to do as an engineer. And it also strengthens my belief that I'm a designer. So I'd like to invite you in a couple of months to do a search, and we will have a website where all of these materials will be available. So any designer can dive in, any future engineer can do some postcards, and any educator can scarf up the teaching materials and use it in their classrooms. Briefly, I want to say so many people told me that the timelines look like music. We sonified them. So you can listen to design. Here we go. That is the sound of a novice designer. In the questions, I can play the sound of the more experienced designer if you're interested. I'd like to acknowledge my fabulous collaborators with all of this work, and also say, if you're interested in engineering education research, I provided you with an example in design, but we have many areas we would love to have you join us in the education research space. I'd like to thank NSF for enabling the high school kid who wanted to change the world to do some research to try to help other engineers change the world themselves. And remind you in the end that iterative cascade is where the magic happens, and let you know that once you see a timeline, you will see them everywhere. And I'm open for questions.
Cindy, thank you. Thank you very, very much. We're going to have to probably move on, but you're going to stay with us for the discussion session. Is that okay? And I think we can open it up for questions there. But what a wonderful intersection of engineering, design, and music at the end, right? So I'm almost wondering if the other app is the streaming part of it. But
okay, I'll need an engineering collaborator for that.
I hear you. But we'll talk more about this in discussion session. I think one of the things that I know has happened through your work is really elevating to a large degree the whole status of research itself in the world of engineering education and design. And I remember how much of a challenge that was at one time, if I'm not correct, right? So I'd like to have you elaborate on that, because that really is a movement of a paradigm that's been really important. So thank you very much, Cindy. Thank you.